In this video, we will talk about a new concept, new investment criteria called EAA, Equivalent Annual Annuity. And we will talk about under what conditions this is useful and why. The definition of EAA is pretty simple. It is the cash flow per period with the same present value as the cost of buying and operating a machine. And technically, it is just the net present value over the annuity factor, right? So to understand why this concept is useful, we have to actually compare this to the internal rate of return and the net present value. So let's go over an example. So again, we are looking at two mutually exclusive projects. One project is just a 1-year project. You spend $100 and you will receive $110 back. In case of the other project, which is this one, this is a much longer project, right? You spend $100 and you will receive $30 over the next 4 years. And for your convenience, I calculated the internal rate of return and the net present value. And just like many other previous cases that we saw, their conclusion is not in line with each other. The reason why they do not agree, one of the reasons why they do not agree is there is a difference between the internal rate of return and the net present value on what they call as the reinvestment rate. So in case of internal rate of return, the underlying assumption of the internal rate of return is that the positive cash flow generated by an investment project will be reinvested at the rate of the internal rate of return. So in case of the internal rate of return is equal to the reinvestment rate. Right? So for example, in case of this long project, when the company earns $30 cash inflow, right? And this $30 will be reinvested and earn 7.71% return. So that's the assumption of the internal rate of return calculation. In case of the net present value, the assumption is different. In case of the net present value, the assumption is all these cash proceeds, right? All these cash inflows will earn the rate of return of the discount rate. Okay, so in case of the net present value, the assumption is when the company makes $30 in the first year, this $30 will be reinvested and earn 5% return. Okay, so that's one of the reasons why the internal rate of return and the net present value is different. And that is also the reason why the net present value has limitations in evaluating two projects with a different lifespan. So like these two cases, right? So how do we properly compare 1-year project with a 4-year project? In case of net present value, the assumption is that the first 1-year project will generate, say, this much return in the first year. Then in year 2, 3, and 4, it will generate the market rate of return, which is 5%. Okay. Is that a correct assumption? Well, that's how we calculate the net present value. So when we use the net present value to compare these two projects, right, we have to understand the underlying assumption that in case of this 1-year project, after the project is over in year 2, 3, and 4, everything will be reinvested at the rate of 5%. Okay. What happens if we want to drop that assumption, right? So, for example, if the company can earn this money at the end of year 1 and can reinvest in the same project again. So what happens if this project is recurring project? Okay. So you can repeat this project over and over. In that case, we don't have to assume that, after the project is over, the discount, the reinvestment rate is the discount rate, right? So if we want to compare two projects and want to make an assumption that the project can be repeated, right? Then comparing two mutually exclusive projects with different lifespan can be challenging, right? Because in case of this short-term project, this can be repeated over and over, and this long-term project can also be repeated over and over, and each year cash flow of each project will be very different. So how do we properly compare these two recurring projects, right? And especially given the fact that the reinvestment rate can be different. That's where the EAA comes in. So in case of EAA, the idea of the EAA comes from the annuity factor. It comes from the annuity factor and the present value calculations. So I hope you guys remember that EAA is not really different from the annual payment calculations. So present value of an annuity was annual payment times the annuity factor. So if you are curious about the annual payment, then annual payment is simply the present value over the annuity factor. So EAA is effectively this C, right? So instead of PB, we are using the net present value. So what we will do here is, instead of using the net present value in comparing two projects that are recurring projects, we can allow the project to be repeated and compare the values of these two projects. Okay, so for that, we have to calculate the annuity factor. Okay, so hope you guys remember what the annuity factor equation was. So the annuity factor is one over r times 1 minus 1 over 1 plus r to the power of t, right? So annuity factor of the 1-year project is, when the discount rate is 5%, right? 1 over 5% times 1 minus 1 over 1 plus 5% to the power of 1. Right? Okay, so that's the annuity factor. And in case of the 4-year project, the annuity factor is 1 over the discount rate times 1 minus 1 over 1 plus the discount rate to the power of 4. So this is 4-year annuity factor, right? And because we already calculated the net present value, EAA of each project is the net present value over the annuity factor, right? So what this means is that when you look at the long-term project, has the annual value of $1.8, right? So when you invest in this project, right, over 4 years, each year the company will get $1.80, and this $1.80 can be reinvested at the internal rate of return, which is 7.71%. Okay. Oh no, sorry. This can be reinvested at the discount rate, which is 5%. And in case of the short project, if this can be reinvested, right, and be repeated, then it is equal to making and getting $5 each year. Okay. So obviously in this case, if the short-term project can be repeated, short-term project is actually a better project. Okay, and that obviously is a different conclusion from the net present value. So again, what is the difference between net present value and the EAA? In case of the net present value, it assumes that each of these are one-shot project. They cannot be repeated, and when the project is over, all the positive cash inflows can be reinvested at the rate of 5%, the discount rate. Okay. In case of the EAA, we are allowing projects to be repeated. So if you choose a short-term project, then when the short-term project is over, that project can be repeated, right? In the case of long-term project, again, when the project is over, that project can be repeated. Okay, so under that assumption, when we do the calculation, we find out that the short-term project is actually a better project. Okay, so hope this helps you understand the difference between internal rate of return, net present value, and the EAA.